In this video, we can see how this FCFS scan and CScan scheduling algorithms can be implemented in C language. So for this, as we have seen, we need to insert some address in the form of request to the array. So for that, here we make use of an array D to store the IO request, and number of requests will be stored in the variable n. You need to initialize the head position, head value, that is the current location where the disk arm is located. And this head value will be inserted to the 0th index of the array, and from the first index onwards, the further request that need to be processed will be entered inside the array. Then just d of n plus 1th location, you will be adding some d of n value, that is the previous last request value will be copied to the d of n plus 1th location also. This is done in order to compute the total value. It is some this dot variable will be like some differences will be calculated by the current location, and the previous arm location value will be subtracted in order to find the seek time. So for that purpose, we will be initializing this variable. So when you do this program, you will be able to understand the purpose of using this equation. So first logic is like in case of FCFS, the order in which request is inserted into the array, the same order it will be processed. So in order to calculate the seek time, what you have to do is you need to find the difference between the current and the previous arm location, this head location. So that will be stored in the variable dot, and then if the dot value is less than 0, you need to get the positive value for that, so that you are multiplying the value by -1, or if the value is negative, the obtained value is negative after subtraction, then you need to make it as a positive value. And then in order to calculate the seek is equal to seek plus total. Seek will be first initialized to 0. This process will be continued till it reaches to the last element of the array, and after that, average of seek time will be taken as seek divided by the number of requests that is given as input. So the output will be like, output obtained will be like, you will be inserting the number of requests 5, 100 will be the initial head position, and if 20 requests given is in this form, means order of the request that is being served will be the same. 100 will be the head position. The request that is given in the order as input will be processed. So you need to get the total seek time and the average seek time output you need to take. Then this is the case for FCFS output, and related to the case for scan output also, some requests will be given. So in this case, you have given the output as initial head position is given as 53, and the number of requests is given as 8. So the order of requests that will be served will be 53. Then you need to move to either to the left or to the right, increasing order or to the decreasing addresses in your process. So here it moved to the left, so that is 37, 14, and it moved to the end of the disk, that is 0, and then it moved to the higher addresses like 65, 67, increasing form of the addresses. It moved till it reaches to the last request that is stored in the array. In this case, it doesn't move to the end of the disk, that is the right end of the disk, it doesn't move. If the reverse case, that is if the arm should follow to the lower addresses, higher addresses, means what happens from 53, it will be processing 65, 67, 98, 120, 124, 183, and then it comes to 199. Then it returns back processing the request 37 and 14. In such a case, 0 won't be processed. So the seek time and average seek time will be different for both the cases. So how it will be implemented? Again, you will be getting the number of requests, head position you will be getting, and the head value will be stored in the 0th location. 0 will be 0, that is the left end of the disk will be stored in first index location. Increment the n value by 2 because you are adding 2 values into the array. So you need to increment the value by 2, and at the same time either the 0 will be required or otherwise if 0 is not required means it will be making use of the last, that is 199 it will be taken if the total disk size is 0. Total disk size is 200. Okay, so you need to enter the request starting from the index location 2, and then I is equal to I is equal to 0 to n minus 1, j is equal to 0 to n minus 1. This is the sorting algorithm which will be applied. Any algorithm you can use. You can separately write a subroutine also. And then after performing the subroutine, that is after performing the sorting, you can insert to the last element, that is 199. If the size of the disk is 200, the last track will be 199, address will be 199, 0 to 199. At 199 value you can store it in n index location value, which means if the number of addresses given as request is 8, means after adding the head and the lower address is 0, you will be getting 10. So you will be having the values stored from from 0 index location to 9 index location. Then in the index location 10 you will be storing this 199. Then first after performing the sorting, this insertion will be done, and then what you need to do, you need to search for the head position inside the sorted list. Head where it is being placed. Currently it won't be in the index location 0 because after sorting it might have come in between the list. So once using this statement, you can just identify the head where it is being located. Either you can use this looping statement or you can make use of any search algorithm to identify any particular element from the sorted list. From the after finding the list, finding the head from the list, you need to check whether it need to move to the decreasing order addresses or increasing addresses. So it will check for the least difference. In order to check the least difference, this equation will be used. That is the IO request position minus IO request position minus 1, that index location minus 1, whether it is whether after subtracting the value obtained will be less than the right hand value, that is post plus 1 and post, subtracting the right hand side value post plus 1 and post. If the value is less means it can move to the decreasing order of addresses. So once it is moving to the decreasing order of addresses, it has to first display the head value that is stored in the post location, and then after that decreasing order address from starting from post minus 1 till the end of the disk, that is 0, it will be displayed. And after once it reaches to the end of the disk, means again it need to move to the higher order addresses, which means already the lower order addresses have been processed, then it moves to the higher addresses. So starting from post plus 1, it processes the request till it reaches to the n minus 1 value. That is why it is called as less than n, because it doesn't need to move to the end of the disk. So last higher address request you need to process. This will be done. In order to find the seek value, formula applied will be head minus IOQ of 0 plus IOQ of n minus 1 minus IOQ of 0. So the same result you will be getting using this also. Okay, het minus n of IOQ of 0 plus IOQ of n minus 1 minus IOQ of 0 will get the seek time, and in order to find the average seek time you need to use this formula, seek by n minus 2, because we have added 2 elements inside the array, extra elements we have inserted, that's why n minus 2. Then after, so this is a case when the disk moves towards the lower addresses. If the disk moves to the higher address means it will be starting from post plus 1. Okay, head position will be displayed, and then the right hand side post plus 1 will be taken till it reaches to the right end of the disk. That's why it is called as less than. Here it is given as less than or equal to n, which means the right end of the disk. Elements will be displayed, and then you need to move to the left end, processing the lower addresses. For that, post minus 1 is given and index value greater than 0, because here equal to 0 is not given, because it is not necessary to move to the left end of the disk. It is we need to just process the least, that is the last request in the lower addresses. That's why it is given as I greater than 0. Processing will be done. In order to compute the seek, you need to use the formula IOQ of n minus head plus IOQ of n minus IOQ of 1. And average will be found like a seek by n minus 2. So this is a case with scan. In the next case is like with respect to the C scan. For C scan, if the output obtained for C scan will be like similarly you will be giving the request, some request will be given, head position will be given, maximum track limiter 199, what we have given in the previous program. Same thing you can give. Difference will be based on the processing, where here we have inserted some equal, here we haven't inserted this equal to and all. So that, which means the left end of the disk, it need not be processed. In this case, for C scanner, you need to insert that equal to symbol so that the left end of the it moves to the left end. So processing will not be done. So this statement, that is, once it reaches to the end of the disk, it moves to the other end, and increasing orderly the processing will be done. So some changes will be performed in the loop so that the request can be satisfied. And also seek and average will be how to find the seek and average. Seek will be found as here IOQ of n minus IOQ of post you have to take. Okay, IOQ of n minus IOQ of post plus IOQ of n minus IOQ of 0 plus IOQ of n minus 1 minus IOQ of 0. So by using that formula, you will be getting the seek time, and the average will be found like seek by n minus 3 you need to use for C scan. Okay, n minus 3 will be used. Why? Because in this case, both the left end as well as the right end need to be inserted while processing the request. So you need to insert both the values. Head value you need to insert, lower end address, that is left end address 0 will be inserted, and the right end address 199 also, 199 or 200, what will be the address, that will be inserted, and the calculation will be done based on those addresses. So the max length of the array will be n plus 3. So while taking the average, what you need to take, you need to give seek by n minus 3. So some modification in this program itself, some modification if you give means you will be able to implement the C scan algorithm. So this you can do, try to do by yourself. Okay, thank you.